Hey guys, Mr. Sayre here, coming from a different room in Sayre's lair. Here to talk to you about the next iteration in the e-learning worksheet extravaganza. Did you hear about? Alright, I want to point out some differences with this worksheet than what we've done in the past. But before that, I told you it was a good joke, and I wanted to talk with you guys a little bit about just before giving birth to her first child, why did Mrs. Plum yell, should it, could it, would it? Did it, can't, because she was having contractions. Anyway, all right. Oh, there you go. Yeah. All right. So, did you hear about? We're going to employ some of the same strategies to solve. Did you hear about that we've done in the previous problem? But we're going to do something different about that. Here's what I mean. In the previous problems, whenever we've added or subtracted, we've always had to find a common denominator, right? Now, what we did with that was basically just get a common denominator, add or subtract straight across, and be done with it. We're going to do something different here on these problems with the common denominator. Now, here's how I know to do something different with it. If I look at some of the previous problems, or the previous papers, right? Just for example here, one that I have handy is the Mrs. Plum one, right? Look at each one of them. There's only a plus sign, or, as I kind of scan through, number 5 here, a minus sign on each one of the problems. Okay? That might be the case here on Did You Hear About, but there's also something in addition to that. What it is there's also an equal sign on every single problem. Alright? So here's what we're going to do with this. Alright? One of the things that we're going to do is we are going to, just like we always have, first step is we're going to find the least common denominator. Alright? We're going to do that the same way that we always have. Look at common factors and make sure that all the factors are there from each each denominator. Alright? The second step is once I've found my LCD is I'm going to multiply every term by my LCD. Right? The goal for me in doing that is to eliminate all the fractions. I know none of you, well, maybe for the select few, do not like working with fractions, right? And even when there's variables on bottom, that makes it more challenging. So let's get rid of them. Let's be gone with it. All right? When we're taking a look here at the third step is what we're going to do is, just like I was just saying, we're going to reduce each fraction. Alright, we're going to reduce each fraction. That will eliminate all the need for fractions. And step 4, maybe the easiest, is we're just going to solve it like any other equation that we would. Alright, so let's take a look at a couple here. One of the ones I want to do is taking a look at number 7. We'll take a look at that one first. Notice it's got 3 terms. Okay, so here's what I'm thinking. I want to take a look at each of these each of these denominators and say if they were all being added. I know that's not the case, but essentially, what is the common denominator for those 3 terms? 8, 2, and 4. Well, we know that for this problem, my least common denominator would just be 8. Okay? So what I have done here is I've just completed step 1. Okay? Step 2 says I'm going to multiply that least common denominator, in this case 8, by every single term. Right? So I'm going to put an 8 here. I'm going to put an 8 here, and obviously on the last fraction as well. Before I actually multiply them. Okay? Before I actually multiply it, what I'm going to do is I'm going to reduce each fraction. Now, remember, as long as I multiply all terms in an equation by the same number, in this case 8, I can legitimately do that, right? I'm taking my equation, raising it up 8, and then matching it with this 8, and it's still equal. Alright, so this one, both 8's cancel, and all I'm left with is just that 3x plus 1. Right here, my plus sign carries down. My 8's cancel, my 8 and my 2 reduce to a 4 on top. So now I don't just have a 4, but I also have an x with that, right? So just 4x right there. The equal sign is the next thing that gets brought down right here. And again, I'm looking to reduce what happens here with my denominator, or with my least common denominator and my actual denominator. 8 and 4 reduced to a 2. So really I have 2 times 11. Or if you wanted to simplify that to 22, you absolutely could. Alright, so we're going to take a look here. Looks like I have 3x and 4x. That just makes 7x plus 1 equals, as I said, 22. I'm going to go over here and move it to the next column. So 7x plus 1 equals 22. I'm going to subtract 1 from both sides. That makes 7x equal to 21, and then x equal to 3, right? So again, I could look over here. Looks like right here is 3 is smoking, right? So in number 7, smoking. Alright, let's try one more. Let's try one that actually has some variables on the bottom. Alright, and for lack of a better way of saying it, let's just take a look here at number 9. On number 9, again, we're trying to look at the least common denominator, right? So if I circle this denominator, it looks like if I just break this up, think about this. Let's do the numbers first. 10, 2, and 5. It looks like my LCD would just be 10 if that was the case, right? Let's see if we can divide this out here just so it doesn't seem to cause maybe any more confusion than these actually are. Alright, so we got the number. Let's also take a look at the W. W, no W, W. That means there at least has to be one W for the least common denominator, because all terms have at most one W, right? I don't want to say at least because that middle term does not have the W. So what did I do here? Again, I took my least common denominator and it looks like I multiplied it times each term. So let's go ahead and do that here. Alright, so I'm going to take 10W, I'm going to take 10W, and 10W. And we're just going to reduce it just like we have before. Notice on this first fraction, this 10W's, they just cancel, so it left me with 4W plus 9. The 10W's and the 2, they cancel. So again, I have my plus sign that's brought down. The 10W and the 2, they reduce to make 5W. So it looks like I have a 5W there, but I also have this 3 that's left over. After the equal sign, I have the 10W and the 5W. They just reduce to 2. 2 times 1, just 2, right? Again, obviously you could write that 2 times 1 specifically out. Alright, so let's see what we have here. Looks like we have some like terms. This is 4W. This right here is just going to be 15W. So let's see here. Notice that plus sign carries down. Looks like now I have some W's and I don't have anything to combine with that 9 on the left side of the equal sign. So 4 and 15 makes 19W plus 9er equals a deuce. I could subtract 9 from both sides. 19W equals negative 7, which means negative 7 over 19 should be the same thing as W. And, ooh, that is kind of a crazy looking fraction, but right there it is. Come on, get it. In number 9, we have the word it. Alright, so those are 2 examples that I want you to take a look at to use to complete this worksheet. I am only asking you to do the evens here on this paper. Use the 2 examples as the odds to help you get through it. Feel free to connect with me with any kind of questions. Make sure that you're showing work on all even problems, including questions 7 and 9. Those are the 2 examples that I gave you. That's how you can earn full credit on this one. Until next time, friends.